So today we have a problem, integral of square root of 9 minus x squared over x squared dx, and how to solve this integration problem using trigonometric substitutions. I'm going to explain this elaboratively so you can hopefully understand and apply it to other problems. Basically, there is a table in front of us that we can use, but my point in this video is to explain why this table actually works and how to remember it much better in future. When we have a root of a squared minus x squared, we can replace x with a sine theta, and then later we will use cosine squared theta instead of 1 minus sine squared theta, and then we can integrate problems like that. You may wonder why we need to change x to a sine theta. It comes from the trigonometric ratios. If you imagine a right triangle whose hypotenuse is 3, get 3 because I imagine this 9 is 3 squared, just a squared, and then this leg is x. And then to solve for the other leg, I can say that that's hypotenuse squared, which is 9, minus x squared. And then if you consider this angle as theta, then sine theta is opposite side over hypotenuse. That means x is equal to 3 sine theta. And that's how we get this expression here. X equals to a sine theta. A is 3 squared, so a is 3, and then 3 sine theta. Next thing you might want to do is replace dx to something in terms of d theta, because we change x to theta. So what is the derivative of x with respect to theta? 3 cosine theta d theta. Now let's substitute what we have in our problem. We have a square root of 9 minus, so let's replace x with its equivalent, which is 3 sine theta squared over x squared, so 3 sine theta squared. Now let's replace dx with its equivalent, 3 cosine theta d theta. Now let's simplify this one a bit. So this one will be 9 squared sine squared theta, and then I can factor 9 out. So I can factor 9 out, and then I'm left with 1 minus sine squared theta over 9 sine squared theta, and then 3 cosine theta d theta. Now root 9 is obviously 3, so I get the root 9 out, that's 3. And you see we have 1 minus sine squared theta, but we can change it to its equivalent, the identity cosine squared theta. So that will be root, instead of writing 1 minus sine squared theta, I will write cosine squared theta over 9 sine squared theta, 3 cosine theta d theta. So far, so good. Now, what I can do next is this 3 and 9, I can simplify them, and root cancels power of 2. So what is left on top is cosine theta. Then this is 3, and this 3 and 3 cancel. So what is left is cosine, and then one more cosine here, cosine theta over sine squared theta and d theta. Well, what is interesting, cosine times cosine is cosine squared, and cosine over sine is equivalent to cotangent. So the whole thing here can be written as cotangent squared theta d theta. So I repeat myself again. Cosine times cosine, obviously cosine is squared, and we know from identities that cosine over sine theta is equivalent to cotangent. The same sine over cosine is equivalent to tangent. So I use the identity that we already know. Now, but I need to use one more identity. So let me find more space. All right. Now, I know that cotangent squared theta is also identity to cosecant squared theta minus 1. So I'm going to replace this term instead of cotangent. So let's bring that in. Cosecant squared theta minus 1 d theta. Now I use linearity, so that is equal to integral of cosecant squared theta minus integral, actually I'd write to d theta, yes, minus integral, that's just 1 d theta. And we know that integral of cosecant is negative cotangent. So that is equal to negative cotangent squared theta, and integral of 1, just 1 minus 1 theta, and then plus constant c. We are almost done, but not quite, because our problem was in terms of x. If you look at here, it was like 9 minus x squared over x squared dx. But now what I have here is in terms of theta. How can we change this back to x? We have to refer back to our triangle. So if you look at the trigonometric ratios, so you can find this term in terms of x. So we want cotangent. What is cotangent equal to? Cotangent is cosine over sine. That means adjacent over opposite. So the adjacent to the angle is root 9 minus x squared over opposite. So let's bring that in. So that's negative cotangent. So negative root 9 minus x squared over x. Okay. Over x. Then minus. Now I need to find the angle. I use sine. I already have it, because I know that sine theta is x over 3. So I know that the angle is arc sine or sine inverse of x over 3. So I just substitute theta with its equivalent in terms of x. So that's sine inverse of x over 3 plus c. And that's the answer. It's not really difficult. Just need to do more problems like this so you get fluent. Thanks for watching. I hope you enjoyed the video.